Today we're going to look at the last section of Chapter 12 that will be on the test next Wednesday. And this one goes and continues on with the look at circles, but this particular one will be identifying circles in a coordinate plane or in a graph. And so the first equation we're going to be working with is x minus h squared plus y minus k squared equals r squared. And in this particular equation, the h and the k are the x and y values of the center of the circle. So for example, if we found out that the center of the circle was at 5 and -2, all we would need to do is plug it in, and the equation would look like this. X minus 5 squared plus y minus -2 squared. That is equal to r squared, and let's just say that the radius is equal to 7, so that's equal to 7 squared. So all you do is plug it in, and then technically if you leave it in standard form, then you just have to simplify it. So it would be x minus 5 squared plus y plus 2 squared, because a negative becomes a positive, equals 49. And this format right here is known as standard form. So that's actually what you would leave your answer as. So let's look at another example. So this example is Quick Check 1A. It's found on page 695. And we're going to continue to use the equation where x minus h squared plus y minus k squared is equal to r squared. And just as a reminder, the h would be equivalent to the 3 from the center, and the 5 would be equivalent to the k. So we're always doing x minus the x value and y minus the y value. So as we continue and plug it in, it would look like this. X minus 3 squared plus y minus 5 squared is equal to 6 squared. And if it asks you to leave it in standard form, then all you're really doing at this point is just squaring the radius. So it would be x minus 3 squared plus y minus 5 squared equals 36. And this right here would be your final answer. So that, once again, is writing the standard form of the equation of a circle with a center and a radius that is known. The next part of the section involves us trying to figure out what the radius is, and in this scenario we will know what the center of the circle is, as well as what one of the points is on the outside of the circle. So we'll continue using the equation we were using in the first part, where x minus h squared plus y minus k squared is equal to r squared. Well, if we want to get r by itself, we just take the square root. So in this case, the radius would be equal to the square root of x minus h squared plus y minus k squared. And in this scenario, we will know that the center is equal to, in this case, we'll go with 1 and -3, and that the point on the outside is equal to 2 and 2. 2. So we can do this in a couple steps if you want, but basically we're still just plugging numbers in. In this scenario, we have the center and we have an x and a y value, so we just use those. So the radius would be equal to 2 minus 1 squared plus 2 minus a -3 squared. Continuing that on, 2 minus 1 is 1 squared plus 2 plus 3, or 5 squared. So the radius in this sense would be equal to 1 plus 25, or square root of 1 plus 25, or the radius is the square root of 26. That's a 26 down there. Then from there, if the problem asks you to or then make it in standard form, you just would go back to the original equation, get rid of the point because we don't need it anymore, and we would use this one up here, but now we have the radius. So it would just say something to the effect of x minus 1 squared plus y minus a negative 3 squared equals the square root of 26 squared. So if you simplify that, it is still x minus 1 squared. The negative becomes positive, so it's plus y plus 3 squared. And if you square root, you just get the number inside, so it's equaling 26. So from this one, we worked backwards, and we got 26 as square root of 26 as the radius. We plugged it in, and we were able to get our standard equation. So let's do one more where we go from everything. We have the center point and we have a point on the outside of the circle. So in order to get to the standard form of this equation, we first must find the radius. So remember, if we're finding the radius first, then the radius is equal to the square root of x minus h squared plus y minus k squared. So let's plug in the numbers. So radius is equal to the square root of negative 1 minus 2 squared plus 1 minus 3 squared. So radius in this sense is square root of negative 1 minus negative 2 is negative 3 squared, and 1 minus 3 is a negative 2 squared. So radius would be equal to the square root of 9 plus 4, or radius is equal to the square root of 13. From there, we switch gears. We plug it into the other equation, back to the original very first one we saw on the front slide. And we get rid of the point again, and now we're just working with the equation of x minus h squared plus y minus k squared equaling radius squared. So plug in the center points and the radius, and we now have x minus 2 squared plus y minus 3 squared is equal to the square root of 13 squared. So the standard form of this equation is x minus 2 squared plus y minus 3 squared equals 13. And that would be your answer for the standard form of the equation. The last thing we're going to go over before you get your homework is you'll have a couple questions like this on your homework where instead of giving you what the actual center is and the point on the edge, you just have to come up with that information on your own. And so it's not too bad, you just got to be able to read a graph. So on this one, we see that the center is located here, which means that the center is equal to 2, 2, over 2, up 2. And then at that point, it doesn't really matter what you got to do. We got to figure out the radius, so we need to find a point. So in my opinion, it's easiest if you just do a point that is on the edge and an even number. So I picked this point down here. Okay, so that one would be over 2, down 2. So the point on this would be equal to 2, negative 2. Now, some of you may be thinking, why don't we just count the distance from this point to this point? And that could work, but it won't always work that way. So you need to be able to do that. Otherwise, you can just count that the radius is 1, 2, 3, 4, and we can go from there. So we have two options. We can pick the point like this and then work back like we just did on the previous two slides, or we can just go ahead and plug into the equation. And for time's sake, since I want you to be able to have as much time to work on homework as possible. We'll just use the original equation, which is, again, x minus h squared plus y minus k squared equaling radius squared. So it's x minus 2 squared plus y minus 2 squared equaling 4 squared. So your final answer, or your standard equation, is x minus 2 squared plus y minus 2 squared equaling 16. So make sure you look on Edmodo now for your homework. I'm not making you do all the problems because we're skipping the part in your book where you actually have to work backwards and graph from these. Not that it's necessarily that difficult, but I'm not going to make you do it on the test, so there's no reason to make you do it here, so if it's not going to be on the test or the final. So if you have any questions, you can send them to me on Edmodo. I'll be gone most of Friday and Saturday because of the track meet, but if I have a chance, I will gladly respond and answer them. So good luck, and otherwise I will see you guys Monday.